Yeah, welcome to this bcme unit 3, where we are going to discuss about this robotics and power plants here. So here, first question, if I'm taking, explain the working of a hydro power plants. So power plants is a hydro means in Greek word water it is. So here, a hydropower plant is a facility that converts the potential energy of the stored water into electrical energy. So further, this electrical energy is why we want the final output here through the series of energy transformations. The fundamental working of a hydroelectric power plant is also having a water storage here. It is having a water transport system, kinetic conversion system, mechanical engineering, electricity generation, and transmission system. So what is the work of this water storage? It is a dam constructed across the river. It is also sometimes called as reservoir also. The water transfer transporters kind of controlled gates are there. These control gates are like a piping system. It is also penstock, we can say. So kinetic conversion, as the water flows down the penstock, the potential energy is converted into kinetic energy. The kinetic is further converted to electrical energy. Here you can see this mechanical energy, the high velocity water strikes the blades of the hydraulic turbine also. So I will show all these parts in the below diagram here. Electricity generation. So then the coupled generator produces the electricity. So transmission line is the way of transferring the electricity to the outside world. Here you can see this is the reservoir where water is there. So here we have some gates. So it is the gates are opened here. The penstock is this is the penstock where this potential energy stored here is converting kinetic energy. It is going here. The generator is rotated, and this generator in front rotates the turbines, and this turbine produces the electricity. This electricity is transferred to this transmission system. From this transmission system, it is going out. This water is sent to the rivers and irrigation purposes. So this is the way how a dam is working. So here, this is a reservoir. Here is a gate. Here is a penstock generator and turbine. So this is the process. All the equipments are joined together for the working of hydroelectric power. So if I'm not wrong, I'm taking the second question, that is explaining the working of nuclear power plants. What is happening to this nuclear power plants? So same thing it is also, but only one thing is that nuclear power plant is using here in this section. So here in the function similar to the conventional steam power plants, all the steam power plants is same circuit, but only one thing is changed, that is the first section will be changed in the circuit. But use of a nuclear reactor is used in the furnace. So one furnace is there where you are going to keep their uranium reactor. So the leverage nuclear fission of uranium U-35 or U-38, which is not mentioned, can be used here, which generates a heat and a 1 kg of producing energy equivalent to 4,500 tons of coal. So this much of energy is generated here. This much of coal can be used to what 1 kg of uranium is producing this much of heat here. And so the key components of these are vessel, fuel, moderator, and turbines. So how this is working? Working principle: nuclear reactor creates pressurized steam to the spin the turbines. So you have to rotate the turbines in the power plants. That is the main concept here, which generates the electricity. The main components here, core elements, including a reactor vessel, is also here. So which is using a uranium here. So the example Tarapur, which is in Maharashtra, is the one of the oldest one. Rawat Bhat, which is in the Rajasthan, we are having some of these in India. So here, this is the only shown nuclear reactor here. So you can see this is the fuel rods here. Fuel rods are kept. These fuel rods are connected to the steam generator here. They are generating the steam here. And also inside one wall is given here. And this is a concrete wall. This is a concrete shielding is there. So now what happens here? The fuel rods, uranium fuel rods are kept here. So this is the thermal shielding. So this heat will be inside only if this thermal shielding is there, this concrete shielding is there for this protection of this nuclear not to come outside of this wall. So this is only what we want, the steam generation. So water should be boiled, steam should be made. That steam is used for the rotation of these turbines. In this turbine generates generators produce electricity, it will send. Now this is cooling for the condenser, and then other heat pump will do the same work. So this is a steam power plant which is having a with the help of nuclear power plant you are using. So this is the total section of this nuclear power plant. If I'm not wrong, I'm taking the third question. Explain the working of a steam power plant. What is happening in the steam power plant? The steam power plant directly, if I'm going to steam power plant also, see all are same here. Here you are having turbines, here generator is here. This turbines has to rotate. So here what you are going to do, you are having a throttling wall here. So which is happening this one. So here is a boiler, which is a boiler here. Which is boiler is giving a steam. So directly some production well is there. So one you are getting steam from here to the throttle wall. It is sending this separator mop from this here. The steam is going here, high pressure, low pressure, generating to the grid. Is going. After that, it is cooling purpose coming to this condenser. After condenser, it is going to this again feed pump. This feed pump is again sending to this low pressure. Once it is going to high pressure, and second process it is going to low pressure turbine high pressure. In this steam power plants are generated here. If you are going for this definition, it is a converting chemical energy of the fuel into electricity. So chemical energy is like coals, oils, gas are used, which are used as a Rankine cycle. It consists of four main circuits. So what is that fuel is used here, or air, fuel gases are used, water, steam is used, cooling water to generate a high pressure steam that generates a turbine connected to the generator. Boiler, what is a boiler which burns the fuel to convert water only here. So burning the water into this one turbine is that converts heat energy from the steam into mechanical energy. Generator driven by the turbine to produce the electricity. Condenser cools the lower pressure exhaust steam back into the water. Feed pump, what is feed pump? Supplies water back to the boiler, creating a closed, efficient that one. So explain the working of a belt drive transmission system. So belt drive transmission systems, you can see here directly. I'm going to the figure. So this is a compound belt drive system. See, this is a driver and one is driven. Here also this is a driver, this is driven. See, this is a motor giving first this will this is a driver. This will start rotating. Now here power is transmitted to this big bar wheel. Again with smaller wheel. Again smaller wheel sending to this bigger wheel. Not in this way, the power is transmitted from this place to this place, this place to this place. So this is the what we have to transfer the power from by using this system. Here also by using this belt drive system, here slack side it is and this tight side, it will be tight side, no slipping side. But here this. So sorry, man, that was somewhat missed. This recording was stopped. So I am going to continue this recording, ma. So I think the recording stopped at this place. So here I am going to step it. This is the boiler, turbine, generator, condenser, and feed pump here. So here there is steam is coming here and it is going into the separator. In this separator, first it is entering into high pressure turbine, high pressure to low pressure generator. The power is completed. Then for cooling purpose, this low pressure turbine will send this for a condenser cooling, and then it is again cooled. This one go to this cooling wheel, and this from cooling tower it is coming to this throttle valve. From this again entering into low pressure. So two times you are using this steam for the generation of electricity. So explaining the belt drive system. What is belt drive system? Here the belt drive system is there. This is a driver and this is a driven system. The power is transmitted from one place to another place. This driver is connected to motor. Once the motor rotates the driver, the driver will rotate the follower or the driven section. Again, this driven section is connected to the driver. The driver is rotating driver. So the power is transmitted from this place to this place, this place to this place. So openly saying that power is transmitted without any loss here. Here also you are having slack side and tight side in the belt. Tight side you don't get slipping, but slack side there's chance of slipping here. So let us coming to the definition of this belt drive system. It is a versatile, cost-effective mechanical power transmission belt pulleys to transfer torque between shafts over one moderate distances. So we are having some moderate distance there only it is possible between the belt and the pulley. Timing teeth for positive slip drives are there. So the chance of slip drive system also here. So common types of are flat belt is used, V belt is used, timing belt, which are used in the automotive industrial section. The components, principles, and tensions. You can see the driving pulley, driven pulley, and the belt are used here. The power is transmitted through friction between the belt and the pulley surface tension. The system requires proper tension to operate. So the tension is there here, slack side and tight side also. Okay, the recording was stopped for some time, so no problem. I'm continuing here. So next question I am taking one. This is the chain drive system. I have told this. Directly, I will go to this diagram. In the diagram, you can see this is a driver sprocket is there. This is a driven sprocket is there. So this is same your bicycle chain drive system here. So this is a driver, which is a small sprocket which is driving the big sprocket. Here also, this is the center distance. Here, power is transferred from smaller gear to bigger gear in this one. So in this way, number of but up to limited distance it can be traveled here. So here, chain drive system is mechanical power transmission system which transfers the rotational motion between parallel shafts. So these are these parallel shafts here, one shaft, second shaft. It is a parallel and rotation with a roller chain engaging with a two-tooth wheel called sprocket. These are also called as sprocket, offering a non-slip. So there is no slipping here, but in the belt you can see there is a slipping. It is an efficient, durable solution for the application of bicycles, motorcycles, conveyors, etc., etc. No slipping is there. After belt chain was developed to overcome the slipping chain. The chain drive is a way of transmitting mechanical power from one place to another place, which is a very important definition. Here is shown. Next, sixth question. I am taking the explain the working of a gear drive transmission system. Gate assessment, this is a spore gate system. So let us take a definition. After that, I will explain diagram. So gate drives are mechanical transmission systems uses the intermeshing two-ted wheels gates to transfer the power between machines. So two-ted things are there. So they are having teeth. If having teeth, they will touch. They are direct in touch with each other. Meshing is there. So friction is there. So you are using some fluid in order to transfer the heat from those teeth and water intermeshing two vehicles gear to transfer power between machines. So reducing the speed. So speed will be reduced while increasing the torque. More torque will be there in the gear drive system. Changing rotation, shaft direction. So you can change the shaft directions frontward and backward also. So where before it was not possible and providing precise velocity ratios. How much of velocity you want, that much. It is a highly effective compact used for heavy duty power transmission. Big vehicles uses this gear systems. So it is also used. There is no slippages functions. So here you can see this types of spur gears. This is having a teeth and this is having teeth. The both twists are meshing. It is forward direction, backward direction. The types of gears are spur gears. So here some recording problem was there. You can hear spur gear is there, straight gear is there, spiral gear is there, worm gear, helical gear. Different gears are here. You can see planetary gears, helical gears. So this is directly measured. This is one is vertical direction, one is horizontal direction. Different purposes make we use of this one. But spur gears is a commonly used. So spur gears. He had given an example also spur and helical only. These are commonly used here. So if I'm not wrong, I am taking the seventh question. Explain the working of links of robots. So links of robots means the robot you can show here, So this is a link one, This is link zero. This is link one, link two, So these are the link zero. We'll be counting in the robotics. So link zero, link one, link two. In between, we are having joints. This is the base and end of the arm, which is working for us. So here coming to the definition, the links and rigid structural members, bones are connected by the joints, articulated pairs that allow controlled relative motion. So you can see that these joints is like a bone mass. It's a structure. It's an articulated force which controls the relative motions here. So you can also kinetics chain. You can say this is the skeleton of the robot with five main joints. Are there? One they can rotate. Second one they can twist anti-clockwise, clockwise rotation they can do clockwise, anti-clockwise, revolving, clockwise, anti-clockwise, linear motion, forward motion, backward, orthogonal 90 degrees they can. So providing degree of freedom. Totally 12 degrees of freedom they can have. So here links in the robots, it is structure, it is type, it is function. So links and rigids bodies make the of the robot structure. So robot is made with only rigids and bodies, rigids and links only. Otherwise, it is not make. They connect the joints and provide the backbone of the manipulator types. primarily rigid but can sometimes be part of complex only. They transmit forces and motion from one joint to another joint. So the here see joint one, joint two, but link one, link zero, link one, link two. This is the robotics. Explain the working of joints in the robotics. Joints in the robotics here, kinetic pairs is there. Joints provide relative motion between two links and typically after 1 degree of each freedom. So 1 degree is allowed for one robot. You cannot design. For example, it can go front side or it can come back side. One is possible. It can screw in clockwise direction, unscrew in anti-clockwise. One robot can be developed here based upon that. This it is a primary joint types. You have rotational joints, twist joints, revoluting joints, linear, orthogonal. You can see here this is revolutionary joints. This is a revolutionary rotation one. This joints here prismatic. This can move here. Left and right it can move. So here spherical joints are there. 3 degrees of freedom. Here universal joint. Two rotational degrees of freedoms can be allowed. Rotation plus transition. This will rotate and also it can move up and down. Cylindrical joints. Spherical, universal. These are commonly used to trouble job robots here. You can see rotational joint similar to the hinge. It will give a relative motion. Within relative motion you want, you have to take a rotational. Twisting motion you want, you have to take a this one. Revolving joint, link joints around the axis. A linear joint known as sliding or prismatic joints. Orthogonal, it is a motion in the perpendicular mechanisms. So explain the working of different configurations of the robots. The different configurations of the robots structures prismatic, rotatory, and coordinate system determining the motion work envelope applications. So mainly industries develop Cartesian, cylindrical, spherical, Skara, articulated. So many are there, but Cartesian and cylindrical. Cartesian is XYZ, cylindrical is XYZ with some theta. Thetas are allowed here. So here, if I am not wrong, I will show you here. This is a Cartesian coordinate configuration. See, this is front and move. This will move, and this part will move front and move. This part will front and move. So this is a Cartesian. Only XYZ motions are allowed. Cylindrical, you can see XYZ there. This is the front side, back side. This is front side, back. What? One is clockwise and anti-clockwise. So this is XYZ with the theta is allowed. Here spherical, you can see this one. One is anti-clockwise and clockwise, and this also it can change into translatory motion or circular motion. This is also a front and move and back. This is a spherical one. So this is articulated mode. All these different kinds of rotations are there, where you can see translation motion, clockwise, anti-clockwise, X, Y, Z, all are there here. So this robot can do many works here when compared to this one. This can do many works when compared to this one. This is a simple robot, Cartesian robot here. Features are vertical column and sliding arm, at least one rotatory. So one rotatory, one sliding arm is provided. Polar, you can see rotatory base and a pivotal arm should be there. Now, which is making this Skara robots is highly rigid in the vertical axis. Vertical works they will do for ideal fast, precise making and packing are used here for this one. So last question I am taking. Explain the working of applications of robots here. So what are the applications of robots? Means they are applied for the assembly section, packing section, customer services, open source robots, and also healthcare system, agriculture, manufacturing. All these are making the use of sense of this one. So robotics applications span manufacturing, healthcare, and also logistics are used exploring, focusing on automation, dull, dirty, dangerous tasks to increase efficiency and safety. So this is mainly used for manufacturing. In manufacturing sector, we need for packing sections, assembly sections, healthcare also. We want logistics, loading and unloading. We want here safety. The key issues there, robotics are also doing in the healthcare. Surgery is also done. Some drones are used for agriculture sections. Here, welding, painting also done. So manufacturing industry, industrial roles, automate material handling only here. Health and medicine is there. Robotic systems assist in minimum in savage surgeries. So some surgeries can be done by this one. Logistic and warehouses. Autonomous robots are used for picking, packing, sorting in the large kind. So this is the one. With this, I will be ending the this unit 3, which is very useful for the BCME students. So just you can have this overview also. So if any comments are there, you can tell me. I will be writing an answer.